Hello guys, welcome back to Sapima tutorial. In our lesson today, we shall be considering elements of plane geometry. We started the topic in a previous video, alright? Today we are considering angles between lines. Before we continue, please kindly subscribe to my YouTube channel, follow me on Facebook as well, and share this video to your friends. Now, angles between lines. Each time two lines meet, angles must be formed. I have these two lines now. Angles are formed everywhere at this point of intersection. There's an angle here, there's an angle here, there's an angle here, and an angle here, all right? So let's consider these straight lines. The angle formed on a straight line is always equal to 180 degrees, all right? Consider the angle formed on this line AB. I have this line AB, which is bisected by CD and EF. By this bisection, an angle was formed here, here, and here, all right? If I sum 1, 2, 3, I will obtain the total angle formed on this horizontal line. So to get the angle from that line AB, I will have A plus B plus C. If I add these three angles, they are equal to 180 degrees, all right? Now let's consider line CD, this line. What are the angles that are formed on this line? You see, that is this angle, and this angle, FAB. So if I add F plus A plus B, I will obtain 180 degrees. And lastly on this, I have line EF, this particular line. The angles I have there on it is 1, 2, and 3. If I add the three of them, that is B plus C plus D, I will obtain 180 degrees. Now let's consider an example to drive home what we are talking about. If I have a straight line and there is an intersection like this, let's assume I have this angle here to be 50 and then this angle here to be 75. We are required to find the angle at this third part of the line, all right? To get this, we simply add y plus 50 plus 75 and equate it to 180 because adding three of them gives us 180. Now, make y the subject of the formula. That means I will have 180 minus adding these both and subtracting from 180 would be, that is 125. Now, subtracting 125 will give me y to be equal to 55 degrees, all right? So this third part is 55. If you add this, and this now, 55 plus 50 plus 75, you obtain a total angle of 180 degrees. So anytime you have a straight line, any part of the line missing, equate it to 180 and find it. Now let's consider sum of angles at a point. Let's consider this diagram. If I add all the angles around this center, I will obtain 360 degrees. So I will only say A plus B plus C plus D plus E plus F. If I sum all of them, I will obtain 360 degrees, all right? So anytime you have angle formed around a point, the summation of the whole angle will give you 360 degrees. Consider this diagram now. If here is 125 degrees and here is 55 degrees, let's assume here also is 125 degrees. Find the missing side, x. Using this concept, sum of angles around the point will give us 360. Of course, what we'll do is say x plus 125 plus 55 plus 125 all equal to 360 degrees. Then we make x the subject formula. X is equal to 360 minus the summation of these whole angles, that is 305. If I subtract it, I will obtain 55 also, all right? So here is as well as 55 degrees. So whenever you have angles around a point, summing all of them will give you 360. Let's talk about vertically opposite angles. For every vertically opposite angles, they are always equal. If I have this line now, and here is 30 degrees, the angle formed here is vertically opposite to this angle. Therefore, here must be 30 degrees. So for every transversal line, for every straight line, two straight lines that meet at a point, there is always vertically opposite angles produced. If I have this line and this line passing through this line like this angle here is equal to the angle formed here. The angle here is equal to the angle formed here. So if here is 35, here will be 35. All right, so let's come here. Considering this angle now, considering this line, you agree with me that M must be equal to U. Now, considering the same line, look at A. A will be equal to the angle formed here, which is M, N, and O. All right, so we say O plus N. If I add the angle here, this angle here is equal to the angle here, they are vertically opposite, so it is splitted into two by this line. So I have N and O. So if I add N and O, I will obtain the same angle I have at this position. All right, so these are the vertically opposite angles I have here. This angle facing this one, this angle facing this one, they are equal. Now let's consider parallel lines, angles that are formed on parallel lines. Parallel lines are two lines that move either in opposite or the same direction, but they can never meet at any point. This can be moving like this in this direction and this in this direction, but the both of them can never intersect. All right, so these two lines are parallel. Now, if a line cuts across the both of them, we call that line transversal. Take note, this line is called transversal. And whenever we obtain a transversal on parallel lines, angles are formed. So let's consider the relationship between the angles that are formed on parallel lines. If an angle is formed inside here and here also, we say they are alternate and equal. If here is A and here is B, then A is equal to B. Take note, they are alternate. We call them alternate angles. Alternate angles. Both of them are formed inside, but on different sides of the transversal. That is what we call the alternate angles. Then the next we consider is the corresponding angle. Corresponding angle formed on the same face of the parallel line. Look at this B now. If another angle is formed here, look at this line. The angle is formed under this horizontal line and under this horizontal line. Let's call here C. Now B and C are also equal, but different reason. The reason is that they are corresponding angle. All right, so take notes of the difference. This one is formed under and also under, but on the same face of the transversal. Look at this transversal, both of them are on the same face. But for alternate angles are formed inside. This is inside the parallel lines, but on the alternate sides of the transversal. We call the alternate angle Z angle. Z angle. What we call this one F angle. Look at this, it looks like an F. Looks like an F, but for the Z angle, look at this. It looks like a Z, all right? Now, I can also obtain an angle outside here. Let's look at this. Look at this parallel line. This angle here, A, is formed on top of this horizontal line. Now, let's call here D. Observe also that D is formed on top of this horizontal line. So the both of them, D and A, are formed on the same face and the same side of the transversal. So as B and C are equal, D and A are also equal. And it is also corresponding. All right. So for corresponding angles, they must be formed the same side of the parallel line under, and the same face of the transversal. But for the alternate, both of them are inside and the alternate sides. All right, so let's look at another alternate angle we can generate. Look at here. Here and here are alternate because both of them are inside and different sides. So call here x and call here y. We said that x is equal to y. Now, do you also know that we can obtain vertically opposite angles on parallel lines? Remember what I told you, anytime two lines intersect, vertically opposite angles are formed. So this line is intersecting with this horizontal line. So D is vertically opposite to B, and they are equal. D is equal to B, vertically opposite, all right? Now, X can also be equal to, let's name here Z. Here is vertically opposite, so X is equal to Z. So on parallel lines, we obtain so many lines that are equal, all right? The alternate angles are equal, formed inside and alternate sides of the transversal, then the corresponding angles and vertically opposite angles. These angles are all equal. Now consider this one also. Here, let's call it T. T is equal to Y, vertically opposite. A is equal to C, vertically opposite. B is equal to A, alternate angles. All right, so take note of all of this because when we start solving problems on this, we make use of these concepts. Thank you so much for coming on board. I believe you have learned something new today. Follow us for more, and then make sure you subscribe to my page on Facebook and my channel on YouTube. Bye-bye.